Hello, students. I'm sorry I can't be there with you today. I'm taking care of my little guy who's sick again. So that gives us a good opportunity to switch gears almost completely, and we're going to look at probability. I noticed that when you all were map testing, toward the end of some of the tests, quite a few probability problems came up, and we haven't covered any at all this year. I'd like to think that you did some last year with Mr. Hernandez. He can verify that, but we did not do any, nor do we have any scheduled to do this year. So I wanted to kind of touch on some, just from the standpoint of things that, again, you can add to your arsenal of skills in preparation for next year. So simply put, probability, we'll look at some definitions, and you have your red notebook with you. I will kind of direct you when I would find it suitable to write some certain things down. We will quiz over this material and some examples, so just make sure that you are following along, doing the right thing. You are on this website already. The link is on the Google Classroom, so make sure you're there. All I did was zoomed my screen in to kind of get rid of the ads on the side, make it a little bit easier for myself to focus. So, probability. Here's a problem. A spinner, off to the side here, has 4 equal sectors, yellow, blue, green, red. What are the chances of landing on blue after spinning the spinner, and what are the chances of landing on red? So, let's see. If I actually spin this thing, there's a spin, and I can stop it whenever, and it lands on green. Okay, so if I spin it again, now there's a difference between an experiment and a trial. So again, and that lands on yellow. Okay, I'm looking for blue or red. So you can tell by the circle, it kind of looks like a Simon game. I don't know if you've ever played that. Because the pieces are equal, and there are 4 pieces, you have a 1 in 4 chance, or 25% chance, or 1/4 chance of landing on any of the colors before the spin. So chances of landing on blue are 1/4, or 25%. Chances of landing on red are 1/4, 25%. How is that true? Well, simply put, probability is the outcome divided by the total number of possibilities. And over here, I have 4 possibilities. Blue is one of them, so it's 1 out of 4. Same idea here. Red is one of the 4 possibilities, so it's 1 out of 4. Equal opportunity or equal chance for each one. So I would strongly recommend writing these down in your red notebook so that you have them. An experiment is a situation involving probability that leads to outcomes. So an experiment is a situation involving probability that leads to outcomes. We kind of cut some of the words out to simplify our definition there a little bit. Example, spinning a spinner is an experiment. Spinning a spinner. I'm going to theoretically spin the spinner more than one time. So the fact that I am engaging in that particular situation more than once would indicate that an experiment is taking place. An outcome is simply a result of a single trial of an experiment. So again, an experiment consists of multiple trials. One result is an outcome. So an outcome in the above would be any of the 4 colors. Whenever I spin the spinner and it stops and lands on a particular color, that is an outcome. An event is one or more of the outcomes. So it's very similar. Events and outcomes are sometimes confused, one for the other. An event is what actually happened. The outcome is what could possibly happen, if that makes sense. So there are 4 outcomes in the above situation or experiment. 4 possibilities, yellow, blue, green, red. That is before I spin the spinner. The event is what actually happens. So I spun the spinner the first time and it landed on yellow. That was the event. I spun it and it landed on yellow. And I spun it again and it landed on green. That was another event because it was something that actually happened, took place. And then probability. Probability is simply a measure of how likely an event is. So it's sort of predictive in nature. in terms of getting an idea of another way to say it is odds. What are the odds of this happening? Probability and odds essentially mean the same thing. So it obviously does not always work out that way where the event outcomes match up, but the idea is, in theory, if you have an equal chance of spinning the 4 different colors, that if you spun the spinner 4 times, you would get each color once. Obviously, that would not necessarily happen, but that's the idea. At any rate, to measure probabilities, here's what we do. You're going to see some notation that you may not be familiar with. Anytime you see something in parentheses, for example, this big letter P stands for probability. So this essentially means the probability of A, and whatever A is an event. So probability is simply the number of possibilities over the number of possible events over the total possible outcomes. So in the previous example with the spinner, there were 4 possibilities. And like if I was saying, what's the probability of blue? Blue, there's only one way that blue can happen, is if the spinner lands in the blue area out of 4 total colors, so that probability was 1 out of 4. Okay? Probability of event A is the number of ways that event A can occur. So if I look at this example 1 a little bit more closely, you can see that again there is an equal opportunity for each of these particular experiments to take place. A spinner has 4 equal sectors colored yellow, blue, green, red. After spinning the spinner, what is the probability of landing on each? So the possible outcomes, again, outcome means before I actually do it, what are the possibilities? So the 4 possibilities are yellow, blue, green, and red. Probability of yellow means that the 1 yellow section out of the total number of sections, 1 out of 4. Probability of blue, same thing. The blue section divided by the total number of sections. The green, same thing. Total green sections divided by the total number of sections, all colors. Red, same thing. Red divided by total. Okay, you get the idea. That's with a spinner. Obviously, it can have more pieces, more colors, and etc. You get the idea. Next common experiment is rolling a die. You've heard of dice. Dice is plural, die is singular. So I'm only rolling one of these cube-shaped pieces. It's called a die. What is the probability of each outcome? So if you understand dice, you know that the numbers 1 through 6 are located on each die. And if I roll a die, theoretically there is an equal chance of any of the 6 numbers coming up. So the possible outcomes obviously are 1, 2, 3, 4, 5, 6. Outcomes are what are the possibilities before I actually roll. And then obviously when I actually do the experiment, you're going to find that things may not exactly work that way. But at least from a predictive standpoint, you could predict there's only one 1 on a die out of 6 total numbers, so that probability is 1 out of 6. There's only 1 2, there's only 1 3, there's only 1 4, there's only 1 5, there's only 1 6. So the probability again is equally likely for any of the 6 numbers to turn up when the die is rolled. Probability, let's take this, probability of 4, probability of rolling a 4, for example, would be 1 out of 6. So 4 out of the 6 total numbers. Okay? So again, those are 2 of the examples, and then it even gets to more specific examples. For example, what's the probability of an even number? Well, on a die, you have the numbers 1 through 6. 2, 4, and 6 are even. That's 3 of the 6 numbers. So again, 3 out of 6. And then traditionally what we do is anytime there is, we were expressing probability as a fraction, we're going to simplify. And 3 out of 6 is simply 1/2. So there's a 50% chance of rolling an even number, which then obviously there's a 50% chance of rolling an odd number. Okay. It also says that experiment 2 illustrates a difference between an outcome and event. An outcome is what happens, or what I'm predicting is going to happen before I actually roll. The event is what actually happens. Okay. So then there is the common situation of drawing a marble out of a container. Now this is going to be different because the percentage or the likelihood or the probability or the odds however you want to think about it, is not going to be equal for each of the possibilities. Okay, so a glass jar contains 6 red, 5 green, 8 blue, and 3 yellow marbles. So first of all, there are not the same number of each color of marble. That's important to understand. If a single marble is chosen at random from the jar, what is the probability of choosing a red, a green, a blue, a yellow? Okay, so in other words, each of these particular outcomes is individual in nature. And what I'm trying to do is predict what would happen in a perfect world if I reach into the jar and pick out a marble. Okay, so again, it does not tell me what the total is, so I would have to add all of the marbles together to get the total. 6 plus 5 is 11, plus 8 is 19, plus 3 is 22. So there are 22 marbles in the jar, 4 different colors. They are not an equal amount of each color. So the total marbles is the denominator of this situation, 22. And then if I can simplify by potentially dividing by 2, I would do that. So at any rate, probability of red marble is how many red marbles are there? Well, there are 6. How many total marbles are there? There are 22. So the probability of drawing a red marble is 6 out of 22, which simplifies to 3 out of 11 because I divided the top and bottom by 2. The probability of drawing a green marble. Well, how many green marbles are there? There are 5. The total number of marbles is 22, so 5 out of 22, right? The probability of blue, how many blue marbles are there? There are 8. 8 out of 22 total marbles gives me 4 out of 11 when I simplify, dividing the top and bottom by 2. And then lastly, probability of yellow, excuse me, is the number of yellow marbles, which is 3, over the total, which is 22. The outcomes, again, in this experiment, are not equally likely because there are different numbers of each type of marble. You are more likely to choose a blue marble simply because there are more blue marbles than any other color, if that makes sense. You're also least likely to choose a yellow marble because there are the fewest amount of yellow marbles than any other color. So far, so good. By the way, at any time during this, you need to pause, go back, play it again. Please do that. I am trying to go relatively quickly because, this is not necessarily world-breaking stuff. All right, how about pick a number between 1 and 5? Well, I have an equally likely chance of choosing any of those 5 numbers. So the probability of 1 is 1 out of 5, probability of 2 is 1 out of 5, etc. Each of the probabilities for a single number is exactly the same. Now, let's throw in some different ideas here as we did before. What is the probability of an even number? Well, in this case, excuse me as I yawn, it's past 11 o'clock, the die had an equal amount of even and odd numbers, so the probability of either was equal. Here, I don't have that. I only have 3 odd numbers. I'm sorry, I have 3 odd numbers, 1, 3, and 5, and I only have 2 even numbers, 2 and 4. So it's actually less likely, or it is a lower probability, that I have to draw an even number versus an odd. So again, the number of even numbers, 2 and 4, is 2 out of 5 total numbers. Probability of an odd number is the number of odd numbers, 1, 3, and 5, which is 3 out of a total of 5. So again, in this case, there is not an equal chance for drawing odd or even, simply because there are more odd numbers. In conclusion, the probability of an event is the measure of the chance that that will occur as the result of an experiment. Probability of an event A is the number of ways that A can occur divided by the total. All right. We're talking about probability in terms of probability. This means the probability of A. All right. I'm not going to get into great detail on this notation here at the bottom. We're simply going to get into the actual exercises. So here's what you're going to do. We're going to pause the video. You are going to answer these questions. There's really nothing else for me to do in terms of checking this with you, because when you click on any of these choices, you're automatically going to be told whether you are correct or not, and you can kind of go from there. When you are finished with these 5 questions. You are going to go directly to IXL, and you are going to do the 8th grade skill for probability, which, if I check my plans, is 8th grade EE1. We're going to go to EE1 in IXL, which has to do with probability here. Okay, so go ahead and take a few minutes to answer these exercise questions. It says that feedback is going to be provided. Please take your time. Don't rush through this just to get it done. When you are done with this, the rest of your time should be spent. At minimum, you should master EE8 today because it is probability and it's relatively basic. If you do well on this, you should do well on the IXL skill. Please get those 20 before the end of the week. There's no excuse not to. 20 out of 20 on a quiz would do very, very, very well for a lot of you. Please don't miss that opportunity. Have a great day. Hope to be back with you on Wednesday, and we'll see you later.